Hey everyone, welcome back to another video here on DarkSec. I am Dark, and today we're going to be taking a look at the RustScan room on TryHackMe. With this, we're going to learn how to use the new, well, relatively new at the time of recording, RustScan tool by bsexan on Twitter. I'll link the repository for this and then their Twitter as well in the video description below. This is a version, or I think the correct way to say this is an abstraction layer for, or a wrapper rather, for Nmap that speeds it up using the power of Rust, which is really cool. That being said, let's go ahead and dive right into task 1 about RustScan. RustScan is the modern day port scanner, capable of scanning targets in less than a second, extensible scripting language, allowing you to write scripts in Python, and more. This room will teach you all there is need to know about RustScan. I think there might be a little bit of a language barrier in this room. You can find RustScan's GitHub repository here. There you go. So we'll go ahead. We'll start the machine here. I'm going to do all this on the attack box, so I'll show you how to get the tool set up on there. I can't remember if it is installed already. I think it might be at this point. We'll go ahead and mark this first task as complete, and note that I got a streak. And jump into task 2, installing RustScan. The installation procedure of RustScan is very easy. So note if you're on Mac OS, Arch, Docker, or any other Nix OS or any other operating system other than Debian, there are installation instructions here. We're going to go ahead and do this for Kali, which is what the attack box is based off of, in just a moment. So we'll go ahead and go to the RustScan repository on here. It looks like there's just a .dev file, and then we just need to install it using the dpackage-i command. One note, if you are using the free version of the attack box, you don't have internet, you will need to download this, and then you can either upload it to the machine. I like to use a tool called Updog or something like that, or you can use SCP. Any of those will work. The biggest thing to be aware of is if you are using the free version of the attack box, it might just be easier to do this on your own Kali machine. This is one of those that being able to actually install the tool and having internet access can make it pretty much easier. Especially because I would imagine this will probably need to pull some, it might need to pull additional libraries with the installation. I'm going to go ahead and pause the video. When we're back, this will be loaded and we'll start the installation process. All right, and we're back. Let's go ahead and close that. Then I'm going to grab the RustScan repo link from the first task and open up Firefox. Actually, you know what? No, we're doing this via the command line because I don't need Firefox for this. Wait, nope, we're doing it via the releases. What am I talking about? So yeah, we are going to do it via the Firefox. GitHub.com/RustScan and pull this up. We'll go ahead and pull the releases for this. Close that. Let's see. Here, let's go ahead and pull that. Download the .dev file. Here, I'm going to go ahead and copy this link. And we will put it on our clipboard to make things even easier and paste it in. There we go. Oh, that's wonderful. Oh, that's so much easier. You can also install this via the GUI if you want to. I'm going to do it with the command line just because it's a good skill to know how to have, or to have rather, and it's just going to be in our downloads folder. So we'll mark that as complete, and we also downloaded the .dev file, cd downloads, ls, maybe. Oh, you know what? The Firefox browser is not running as root. Show all downloads. And let's see what folder this is actually in. And this is why I'm doing it. Oh, okay. It just downloads to the root folder. That makes it even easier. Cool. This is why I'm doing it in the attack box, just because I don't want you guys to get hung up on this. So cd ... and we can see RustScan is there. Then we need to do the dpkg-i for install, and then RustScan. And we're running as root on this, so I don't need sudo. We'll give it just a moment. We'll mark this as complete, and then we should be able to just type RustScan? Maybe. It's thinking about it. There we go. Cool. So we can see that it's installed, and we'll go ahead and jump into task 3, Accessible. RustScan is actively accessible. That means we use continuous integration testing to ensure accessibility needs are met. This is something that B has put a huge focus on, and hopefully we'll have a blog post out soon by the time of this recording going live on accessibility within hacking, and then manually testing that accessibility as well. This is important because accessibility is important in hacking. Hacking, by and large, is a very inclusive field. It's very age agnostic. It's very gender agnostic as well. It's a very accessible field, and it's becoming more accessible just because hackers are very, generally speaking, very inclusive individuals for the most part. So you can see where accessibility becomes a big factor in our tools. Hacking isn't just inaccessible, it's the opposite. It's actively discluding members from the community because of some issues they were born or developed that they cannot help. It is a basic human right to extend everything that we do to be accessible to everyone. In the same way, it is right for you to get healthcare and to get education. Around 15% of all people suffer from some sort of disability. See this blog post for more statistics on why accessibility is important, or the World Report on Disability Statistics. This is a blog post that B did. I guess this is on the Making Hacking Accessible. We'll probably have a copy of this up on the TryHackMe blog at some point. Otherwise, I do recommend checking this out. This is one of those things that I don't want to get too far up on a soapbox. If you know anyone that has a disability, you talk to them about it. It's actually really interesting. Myself as being, a relatively able-bodied individual, there's a lot of things that you don't necessarily realize, and it's very subtle. It's very interesting. It's almost like taking a walk in someone else's shoes for a day. And I definitely recommend talking to someone about that. There are little things like even this ASCII art up here that if a screen reader will do a very poor job with interpreting that, but I digress. We'll go ahead and mark this as complete. I definitely recommend checking that blog post out. If I remember, I will have this linked in the video description, specifically just because it's very interesting. And we'll move on to task 4, Fast. RustScan is fast, but why? In short, this is due to the low-level kernel networking, because Rust can interact directly with the kernel. It's much, much faster. It's written in a fast language. Rust is very well known for being very, very fast. I think it actually has a quicker... it's faster than C in some instances, just because of the way that it is incorporated with the kernel. When I say that, just for if you're not familiar with how programming actually works, in summary, whenever you are using a command or something, it has to do something with the base of the operating system for the most part, the base of the operating system being the kernel. The more you can interact directly with that versus going through different layers, like so Python is a bunch of abstractions, the more you have to go through, and I'm probably butchering this a little bit with the explanation, the more you have to go through, the slower it is. If you can interact directly with what you ultimately want to do, it's the same as going through the shorter line when you're checking out at a grocery store or something like that. All right, asynchronous scanning. Multi-threading is slow due to the context switching cost. Async is fast. See my Rust room for information on this, and I definitely recommend checking that out. Long and short, you scan multiple targets at once because, it makes sense. At its fastest settings, the bottleneck is not the program. The bottleneck is your computer, the network link between your computer and the target, and finally the target itself. If your operating system/hardware isn't the best, that'll be the bottleneck, which is actually a good problem to have. You ideally don't want to have your program be the bottleneck. You want your bottleneck to be the raw hardware that you have. And that's actually something that comes up in gaming quite a bit, too. Especially if programs are just not properly optimized. This sounds bad, but some other port scanners have their bottlenecks in the program itself. RustScan is as fast as your system, the network, and the target is. Being so fast is bad, but RustScan can be slowed down to however slow you want. But just know, if speed is your thing, RustScan is where it's at. Now, just be careful with this. Again, at the highest speed, it is I believe, considered to be a denial of service. So you don't want to use this necessarily at the highest speed, which, again, good problem to have because networking hardware is only going to get better. Computer hardware is only going to get better. And having things ready for that improvement it's a good problem. How do you ensure speed? As more features are added into RustScan, slowness tends to creep in unless noticed. As we add more features, the program generally tends to slow down. This is a rule for all programs. More complexity will often mean it is slower, but not always. RustScan deals with this by manually testing on targets, continuous integration that fails if the program is too slow, benchmarking the program and graphing the results, keeping all features outside of the scanning itself. Unless it is absolutely needed, RustScan will not run code before or during the scan, only after. We'll go ahead and mark that as completed. You can see more on that on the GitHub. It's actually very interesting, the testing process that this tool has gone through. Let's move into task 5, Extensible. Now for the largest feature of RustScan. Thanks to Bergaman for working on this one. RustScan is extensible by the RustScan scripting engine, so similar to the Nmap scripting engine, or NSE. This allows you to write a script which runs after the scan is completed, taking inputs of open ports and their respective IPs. RustScan supports these languages: Python, Shell, Perl, or any program which is a binary and is in the path. Scripting engine arguments, rather. RustScan scripting engine, oh my goodness, words, can be altered using the -- scripts argument. Very similar to Nmap in that way. There are 3 possible arguments: none, which means don't run any scripts; custom, which runs all scripts in the scripts folder; or default, which runs the Nmap script or whatever script is in the config file. Default does not need to be enabled, it is on by default. And this is where we can see that RustScan is that abstraction layer for Nmap, where you take the ports that are open and you run the longer scan. Once you've already determined what's open, you pass that over to Nmap and you tell it, hey, I've already done part of your work. Why don't you just focus on these? And it's a lot faster because Nmap takes a long time to figure out what ports are actually open. Python custom scripts. To execute a custom script, we need to install the rustscan_scripts.toml file located at the $home /.rustscan_scripts.toml. The script file should look like, it looks like we just have that default one, and we're going to walk through what that actually is doing. So let's walk through this. Firstly, for reference, this is a basic Python script, and we can see that just here up at the top that it is just calling Python 3. So for tags, it looks like this one is core approved in an example script. We have our developer tag, which would typically denote who made it, and what port or ports are going to trigger the script to run. So in this case, it looks like it's going to call it in Python 3, the script itself, the IP that we're scanning, and then the port. And in this case, it looks like the script file parser stops at the first blank line with parsing. The script will run itself as an argument. With the system installed Python, it looks like it's cut off there a little bit for me. So what we're doing here is we hit a trigger port, and because we saw that that port is open, we can do something else because of that. Where is this useful? For running things like Aquatone or Eyewitness, things like that. Just a nice example. If you hit DNS, you could say, hey, I see that DNS is open. Let me see if I can do a domain transfer. Things like that. So you can see how we can take what we get, and after RustScan is done with what it is, needs to do initially, it's going to go ahead and do what custom actions we want. Very cool. Tags. Tags are categories of scripts. For example, we may have these categories. So HTTP, SSH, and Tomcat. Again, those are just examples. And only wish to run scripts that match these categories. Our config file will only execute the scripts with matching categories. So we can say, we can configure this pretty easily to do exactly what we want our scanner to do. Really helpful, especially if you are in an environment that has, for example, a lot of Tomcat, or a lot of web servers on a very specific port. Maybe in a development environment, you run things on 9080. things like that. Developer, this tag issues who the developer of the script is. So we're talking about the tags up in here. So the tags for the category, the developer is who the developer is. The trigger point is what actually is going to trigger that. So for example, that port 80 that we saw, and then the call format, which is going to be what we are going to call that script with for the arguments. And then we have the code itself. Now everything after this metadata is the code itself. The script will receive arguments via the sys.argv in the format specified in the call_format variable. With this data, we run the script doing whatever we please. So we take our arguments, the data from actual RustScan, provide them as arguments, and then we run whatever code we want. And then contributing/making scripts, we have a folder of example scripts here. If you make a script, please consider contributing to RustScan. Right now, you can submit a pull request to this folder and we'll include your script. Very cool. Running other tools with RustScan. Any tool installed in the system, like Nmap, GoBuster, etc., can be run with RustScan. We do this by default with Nmap. To execute another program, create a shell script which calls that program. So to call Nmap, create a shell script with our RustScan scripting engine, and then the function. So we have Nmap, and then we have very verbose, and then we're specifying the port with -p, and then the port itself, and then the IP that we're scanning. And you can replace this with GoBuster or any program at all. You can see how we can take any program that we want and just take the output from RustScan and just tell it, hey, we were going to do this action anyways. Let's go ahead and just run it. Let's go ahead and jump into the questions. What is the scripting file config called? I'm actually just going to copy it up here, as that name was kind of long. It is going to be the RustScan_scripts.toml file. And we'll put that in there. Can you run other binaries with RustScan? That should be true. Does RustScan support scripts in JavaScript? I'm not sure on that one. Let me actually double check the answer on that to make sure that I'm relaying that correctly. Yeah, that one's going to be false. I was a little confused because JavaScript is for the web browser. You can use it for other things, but that doesn't really make sense in this context because it's not really in the same category as binaries. I digress. Let's go ahead and move into task 6, adaptive. RustScan is adaptive. That means it changes how it works to better suit its environment. We call this the adaptive learning feature set. Some of the features included or being worked on are adaptive output or outbound SYN timing to optimize the speed of scanning. So it's going to see how fast, so while RustScan scans the target, it learns how it reacts. How fast is it to scan? Does it respond quickly? How far away? So if it's responding slowly, it's going to have to slow it down a little bit. Very cool. By using this, the RustScan molds itself so that it is the fastest scanner for any target. Custom top ports. You may be familiar with the top ports feature of other scanners. It'll let you scan the top 100 ports on the internet. But the top 100 ports on the internet are not often the top 1,000 ports, rather, you might come across. Corporate networks may have unusual ports open. Capture the flag events may have unusual ports open. As an example, port 311, or I'm going to guess that this is meant to be 31337, so 3 and then leet, is used a lot in CTFs because of leet. Yeah, it looks like there's a small typo there. This port is not in any top 1,000 ports list. RustScan learns what the most commonly open ports are for you and adapts itself. So if you have this on your CTF machine, it's automatically going to start learning that, hey, I'm seeing a lot of these open on these ports. Let's check this right away, and maybe it's going to be open right away. Your computer is not the same as my computer, so operating system adaptation. So why run the same scan settings? macOS devices have an open file limit of around 250. That means they can only make 250 connections at any given time. Kali Linux has around 90,000 open files for the limit. If we built this for Kali Linux, it would break on a Mac, which does not support that many open files. RustScan learns about your operating system and adapts itself to better suit you and your computer, as well as the networks it is scanning. Configuration file. All of this information is stored in a configuration file. Onboarding a new pen testing intern, send them your config file, and their RustScan will be optimal from day one. We'll go ahead and mark that as complete and move into task 7, scanning time. The tool is really amazing in terms of scanning. It can scan all the ports really fast and then pipe the output to Nmap. Now in this room, we'll scan our vulnerable machine. Basic format for RustScan is RustScan-R for, and then ports, -A for the target IP, and then -- for Nmap commands. Here's a full list of things you can do. So multiple IP scanning. You can scan multiple IPs using a comma-separated list, like so. And we can see an example just down below with RustScan-A, and then we have our local port, or local host, and then quad zeros. Host scanning. RustScan also can scan hosts, so we can use host names instead. So for example, www.google.com, and then we can see that we have just our normal IP at the end there. CIDR support, so we can use CIDR formation, -A, and then we have a range here. Host files and input. The file is a new line file separated list of IPs /host to scan. So here we can see that we have this is the same as maybe just an input list with Nmap, and we can see that they're just listed there. And then the argument is -A, and then we have our host file in single quotes. Individual port scanning, we can do that with the -P option, and it'll, for example, just scan for port 53, just seeing if DNS is open. Multiple selected port scanning, you can input a comma-separated list of ports to scan, so we can see similar to the hosts and the IPs, we can just use commas. And then ranges of ports here. So we have a range of 1 to 1000. And then adjusting the Nmap arguments, we can change that by doing the 2 dashes, and then at the end there, it just takes Nmap arguments. And then random port ordering. If you want to scan ports in a random order, which will help with not setting off firewalls, RustScan you can run RustScan like this. So we have this one option at the end. So we have --scan -order and then random in double quotes. And it's saying that there's the output rather there. So we can see that we can just specify that as random. Try running the scan for all ports. We'll go ahead and take a look at that here. So we'll go ahead and run RustScan-A. And let's see what my target is. So we have 10, 10, 20, 108. And we'll give it just a moment. So it looks like we have 22 and 80. We'll see if that's correct. How many open ports do we find under 1,000? That's just going to be 2. There we go. Perform a service version detection scan. What is the version of the software running on port 22? We can do that with -P22 to specify that we're going to use Nmap arguments, and then -SV to run service version enumeration. And let's give it just a moment. It looks like it is OpenSSH 6.6.1 P1, and there we go. Perform an aggressive scan, so -A. What flag isn't set under the results for port 80? We can go ahead and go up. And we'll change this to port 80 because that's the only one that we care about here. And then for Nmap flags, we want aggressive. We'll give it just a second. And since it's running an aggressive scan, it can take a little bit longer, but it looks like we have our information back. So it looks like we have the HTTP only flag not set. Only. And then using this tool and scanning can save a lot of time. No kidding, that was very fast. This is actually the first time that I've played with RustScan. That was incredibly fast. Make sure to use it in your pen test. I certainly will be after that. That was actually pretty impressive. I have been told that this was a fast tool. I'm pretty blown away because this aggressive scans take a long time. If any of you have watched my Nmap video, you can see just how long that takes. Scanning in the TryHackMe network certainly is fast, but that was ridiculous. Let's go ahead and move into task 8, the final task, RustScan quiz. A short quiz on the more useful switches that we can use with RustScan. All you'll need for this is the help menu for RustScan. Include all parts of the switch unless otherwise specified. This includes the dash. For example, we would specify the -Z switch via RustScan-Z. First, how do you access the help menu? I would imagine that's -H, and there we go, that is correct. I'm going to clear the terminal with Control and L, and we'll run RustScan-H, and I'll make this full screen over here too. Often referred to as quiet mode, what switch can do this? I would imagine it'll be -P or -Q. We will see. Here, I'm going to pause it for just a moment. I will go ahead and find that, and we'll be right back. All right, so I might be missing it. It is -Q. I'm not seeing it over there. That's something that I would say is pretty guessable. Typically, these are going to be just shortened command or dash commands based on the first letter. I'm not seeing it over here. I might just be missing something. What switch can help us scan for a particular range? So it looks like we have a -R for range right there. There we go. What switch would you use to find out RustScan's version? This is a pretty common default switch, but you can see it right here as well. It's just going to be -V. What switch will help us select batch size? I would imagine, yep, there we go. That's going to be -B. And the batch size for port scanning, it increases or slows the speed of scanning, so how many ports it's actually scanning at once. And then what switch can set timeout? I would imagine that's probably -T, and sure enough right there, we can see -T is going to be the timeout switch. And there we go. That's going to do it for the RustScan room. As always, I will have the TryHackMe Discord and subreddit linked in the video description below. If you have any questions, feel free to hop in there and ask away. I will have the DarkSec Discord linked too. If you enjoy content like this, please subscribe to me on YouTube and follow me on Twitter. Otherwise, until next time, happy hacking.